Possible तैयार. Hello students, welcome in this session. Today we came with another new research question. But before that, if you haven't seen our previous two research questions, it is recommended that please check out those questions. The link are also provided in the I tab. You also check it. So without wasting any time, let's start the session. So you see there is a question, if you able to read what is written, it's a very interesting thing is written. Can inverse of the magic square matrix is also becomes a magic square matrix? So what did you understand from this question? I think it's a very new type of question. You haven't um, feel this question before. So in every class we are also suggest to which class students will understand. It is only for class 11 and 12 students is able to understand it. If class 10 students are also watching, then it is on their own interest. We are not here to uh, uh, make any problem, creating any problem. So first of all, you see there is a word written magic square matrix. First of all, here written is a matrix, and second word is written as magic square, right? There is two words written, magic square and matrix. Let us divide these two terms and we understand the whole thing in a once. Uh, First of all, you think you can split it like this. Um, right, wait. Magic square plus square matrix. Sorry students, my handwriting is not good now, but I will try my best to give understandings to you. So we are splitting this one word in two terms. One is a magic square and another one is a square matrix. Now you will, I think 50% you maybe understand what it does mean. See, square matrix means is a matrix of order n by n, right? Square matrix is a matrix of order n by n. We all know very frequently. And what is a magic square? It is a magic square. Uh, it is a magic square in which there may be three or four elements. Each row or column having same number of elements, and each sum will give the same result. If you adding from horizontal this side or this side, or diagonally if you adding, you will get the same results, right? Okay, so here we want have a magic square. Let me show you the magic square first. Just a minute. Actually, due to typing error, we are distinctly erase that magic square here. But let me show you one magic square which satisfies the relation. So see, this is a magic square. It is also in the same number of rows and same number of order, and it is also a 3 by 3. Can I say it's a 3 by 3 matrix, right? It's a 3 by 3 matrix and it also a square matrix. So magic square matrix means we are just making the magic square as a matrix only, because it obeys the square matrix, the condition of the square matrix it obeys. Okay, so let us show you one magic square. I'm writing in the upper part a is equal to 2 7 6 9 5 1. It is 9. Okay, little bit typing problem, remaining all right. It is 9. Okay, now 4 3 8. It is a magic square. Okay, okay, let me write it once again. I think here it is very good to show you. Here we have a matrix square, I mean magic square matrix 2 7 6 9 5 1 and 4 3 8. So let us understand once again what is a magic square matrix saying. Then we will go to the main problem for which this session is conducting. So it is a square matrix, right? A is a square matrix of order 3 by 3. If you see from row side it is 3 elements, from column side also 3 elements. And if you add suppose 2 7 6, if you add you will get 15. If you add from this from column 2 9 4, 2 9 11 plus 4 also 15. If you take second column, if you add it is also coming to be 15, and third column 15. Second row also give you 15. I think you are that much have the ability to add these numbers or elements. Also that in diagonal also you see. Let us this is the diagonal. If you add it 2 plus 5 plus 8, you also get 15. And also from this diagonal also, of course this is not a diagonal in the matrix definition, but if you see it is also coming 15. Okay, so this is a magic square matrix. So it is always the definition of a matrix, more precisely the square matrix, and also it is a magic square also. It is magic square also, and also obeying the definition of matrix. So if you combine these two, it is called a magic square matrix. So this question also having an interesting question, that if you want the inverse, it is asking the inverse of this magic square matrix. It is asking the inverse of the magic square matrix. So that means you have to find the inverse of a square matrix. That is the main point. If you understand in a simple way, it is saying that you have to find the inverse of a square matrix. That's the question. But that square matrix is not a ordinary square matrix. It is a special type of square matrix which we know now. It is a magic square matrix. So if you find the inverse of the magic square matrix, will it be become again a magic square matrix? So suppose you have you know your techniques where how to find the inverse of a magic square matrix. Okay. Okay, I also mentioned that engineering students can also see this, because why I have specified engineering students, because the methods we will use here maybe is not present in the class 11th and 12th books, but you will be interesting about knowing the things, the contents which we will cover here. So ultimately it's saying that I have to find the inverse of this square matrix, and I have to check the condition, will satisfy the condition of the magic square matrix or not. What is that condition? The condition is that in every column addition or row addition or diagonal addition, the sum of that elements will be same or not. This is the main question of this, sorry, this is the main meaning of this question. Today my English is not good, so please try to face it, try to manage it. See, okay, next. So in every class we also discuss the contents through which we will going to solve the problem. The first one is a multiplication of a matrix. What is that? You know, suppose this is 1 2 by 2 matrix and this is 2 by 1 matrix. So you will get what is the uh, nature? It will be coming 2 by 1 matrix. Okay, because this 2 and this 2 in both sides are same, so it is omitting remaining 2 are joining, you will get 2 by 1 matrix. So like that, this is the concept of multiplication of matrix. And then we have to cover addition of matrix. Remember that multiplication of matrix is possible in any kind of order, but the notation should be same in both sides. But addition of a matrix is only possible for equal number of orders. For example, if you take a 2 by 3 matrix and I will ask you to add with 3 by 2 matrix, is it possible to make, is it possible to add? No. But if I asked you to multiply these two matrix, if I asked you to multiply these two matrix, definitely it is possible. You will get a 2 by 2 matrix, right? And you know these things. Just I am going to recall it so that when we will going to solve the problem, you will not face any difficulties over there. Okay, so these two are already known to the class 11th and 12th students, but for them the new things we are going to cover here is the eigen characteristic of a matrix, characteristic equation of a matrix, and inverse of a matrix. Inverse of a matrix, you know. Okay, so let us go into the concept, then only I can give you the knowledge of these two chapters, eigen characteristic and characteristic equation. Because see, if I ask to class 11th and 12 students to find the inverse of a matrix, they know that they can find this method. A inverse is equal to 1 upon det of A into adjoint of A, right? They can find the value using this method, but I am suggesting that they should not go with this method. They can go, they can find the answers, but the elements are so much complicated that finding the adjoint maybe give some calculation mistakes and you may not get the answers correctly. Although you can uh, use this method, we have no objection to it. Okay, so let us go into it. So the question is this one: the consider the following matrix A as a square matrix. Okay, so let us see what's written. Okay, let us write down again the matrix. I'm writing here the matrix. It is written as 2 7 6 9 5 1 and 4 3 8. Okay, so this is the matrix. You can check here. This is the matrix given. I am written here. So the first step is that to find the determinant of the square matrix, and we have to check it is 0 or not. Definitely you know that when the determinant of a matrix becomes 0, then its inverse does not exist, right? You know, I have written the formula right now. A inverse is equal to 1 upon determinant of A into adjoint of A. I have written this one, but if determinant of A becomes 0, it is not defined. So that means inverse does not exist. So that is the thing we have to check over here. So now you also calculate with me, and I'm also calculating the determinant. Okay, so I'm doing directly these things you know already. 2 into 5 into 8 minus 3 into 1 and minus times 7. I'm going in this way. Okay, so minus 7 times 9 into 8 minus 4 into 1 and plus times 6, 9 into 3 minus 4 into 5. I have little bit less space, but I am trying to solve it. So 2 times of it is 40 minus 3 minus 7 times of it is 9, right? 72 minus 4 plus 6 into 27 minus it is 4 into 3, right? 4 into 3, which is what? 12. Up to that, after that, if you solve it, you will get the answer as minus 360. After this is just a simplification. If you solve this, you will get your answer minus 360. Okay, now find the characteristic equation of the matrix. So what is this characteristic equation? Engineering students know this, but for class 11th and 12th, I'm not going into detail, just I'm writing the method how to solve it. uh, Here we have a eigen, uh, just very simply I am uh, explaining the concept of this characteristic equation. We have one eigen value, or we say element. We denoted it as a lambda. Okay, so we considered one matrix. So lambda is a scalar. Okay, scalar means it is a element which does not have any dimensions. Okay, like scalar quantities like that. It is just a magnitude. It does not contains any directions. So that means it is not a matrix. Keep remember that it is not a matrix. It is just a element, not a matrix, right? So that's why we have multiplied with this identity matrix. So it is a 3 by 3 order, so I can also write I3. Okay, I think it is visible of course to you. If not, let us rewrite again. A minus lambda times of I3. So what we should do, we will find a, if you solve it, you will suppose find a matrix B. Okay, it is also 3 by 3. It is a 3 by 3 matrix. It is also a 3 by 3 matrix. We are doing the addition subtraction, so you will get some matrix B. Now what you should do, matrix B, the determinant of matrix B you have to equate with 0. So indirectly if I say mod times of A minus lambda I or I3 you can write is equal to 0. Okay, so first of all you have to make one matrix. Okay, you have to make one matrix, then you have to find the determinant and you will get one equation in terms of lambda. So it is a 3 by 3 matrix, so it will coming like this: a lambda cube minus I write b lambda square plus same lambda plus d is equal to 0. Okay, you will get one equation in terms of lambda. Okay, because we are actually find the values of lambda here, but after that you have to do nothing. You have to do nothing. Okay, next step I will explain to you, but let us now try to find the value. Okay, okay, let me clear. Okay, now I'm rewriting the matrix A here. 2 7 6 9 5 1 and 4 3 8. I think you are able to see, it is visible to you. So first of all I will find A minus lambda I. Okay, you also do with me, then you will able to understand. So 2 7 6 9 5 1 4 3 8. So lambda into I, you will get lambda 0 0 0 lambda 0 and 0 0 lambda. You know na I value, I is 1 0 0 0 1 0 0 0 1. So if you multiply it with lambda, so yet every element is multiplied with lambda. This 1 becomes lambda and 0 into lambda becomes 0. So you will get this is the answer ultimately. Okay, so I'm erasing this one. Okay, so after that it is just simplification. So this step I'm doing directly. So you will get 2 minus lambda 7 6 9 5 minus lambda 1 4 3 8 minus lambda. So, okay, this is the matrix, or you can say this is the matrix B. As per the notation I have provided to you, we are considering this is a matrix B. Okay, so now what we should do, A minus lambda I is equal to 0. So let us write down again, uh, 2 minus lambda 7 6 9 minus lambda 1 4 3 8 minus lambda is equal to 0. Just once check it. Okay, everything is right. See, if you not wanted to uh, solve this one, there is a formula for this. If you remember, then it's very good. Otherwise, you have to go with this. So I'm just solving this. 2 minus lambda into 5 minus lambda into 8 minus lambda minus 3 into 1. Okay, next minus 7 times of 9 into 8 minus lambda minus 4. 4 into 1 is 4. Okay, plus 6 into 9 into 3 minus 4 into 5 minus lambda. Did we have space? No. Okay, after that it's just a simplification. It is very lengthy process, but you have to do it. And after solving you will get right. I'm writing here this space. After solving you will get your answer as minus lambda cube plus 15 lambda square plus 24 lambda and plus 360 equal to 0. Okay, wait, not plus 360 but minus 360. Okay, say we have find out the determinant. You will get 360. Here also you will get 360. After solving you will get to this value. This is 24. Okay, now we are taking the minus common, so ultimately we'll get minus 16 15, right? 15 lambda square minus 24 lambda plus 360 is equal to 0. Okay, so why have we did this? Because now using this characteristic equation, it is called a characteristic equation. I am pronouncing this characteristic equation. Just write it correctly. Characteristic equation. Space is not available with me. That's why uh, my handwriting is not good. So okay, here also 5. So what we have to do now, instead of this lambda you have to just put the value of a, and instead of constant you have 3 is what, 3 into 1 so in place of, okay, let me write here. So you have got what, you have got lambda cube uh, minus 15 lambda square plus minus 24 lambda minus, no, minus 3 plus 360 is equal to 0. Okay, let us check it once again. Yeah, so engineering students know this. For class 11 and 12 students, okay, here also written put lambda is equal to a in the given characteristic equation and then multiply the equation by a inverse. So in place of lambda you have to put a, and remember that a is a matrix, not element. So wherever constant is there, like this way, you have a constant. 360 is written as 360 into 1. So in place of 1 you have to uh, replace it with I, identity matrix. Okay, Okay, because the determinant of I is what? 1. So you can think, if I have to find 360i, determinant of 360i, I will get 360 only, right? I hope you are able to communicate the things. Okay, let us do this way. So lambda is replaced by a, 1 is replaced by I. And if you are doing, you are converting, means in your terms we can say we are transforming this equation. See, this is a equation of elements of scalar equation. We are going to transform in a matrix equation. So scalar equation is going to transform into a matrix equation. Okay, so each term will become a matrix. Understood? Okay, this is the transformation we do in engineering mathematics. So I hope you are able to understand class 11 and 12 students. Now see, we have to replace it with a cube minus 15a square minus 24a plus 360. So we cannot write 360. If this is a matrix, this whole part should be a matrix. So we replacing 1 by I. It is 0. This 0 is a 0 matrix. Don't compare with a 0. Okay, don't compare it with a 0. Okay, now it is asked to multiply the equation by A inverse. Now you know that A into A inverse or A inverse into A, both will give you I, and I into something will give the same thing. So let us multiply it. Minus 24a plus 360 into I is equal to A inverse into 0 matrix. Okay, now if you multiply it, so let us, I am going to solve one element, I mean one term, remaining you will understand quickly. So if I multiply A inverse into A cube, A cube can be written as A inverse into A square, right? It will give the same answer. So let us break it out. I have just told you that A inverse into A will become I into A square. You will get A square. Okay. So nothing to do here. When there is a power in the A, it will just reduce when we multiply it with A inverse. So you can do also, like you can also do that method. A inverse into A cube, or shortcut I am saying A power 3 minus 1, you will get A square. Yeah, you can go this way also, but that is a shortcut method. The real procedure of this multiplication is this one, which I have explained, but I suggested that don't go like this. Okay, let us solve this quickly. So this is the phenomena of this multiplication. Why we are multiplying? Because we have to find the value of A inverse. So we have to generate A inverse. Now you will get A square minus 15, this is a square, so you will get a, and this is 24 I will come, a into a inverse is I, okay, and 360 times this I into a inverse will give you a inverse, and a inverse into 0 matrix also 0. So did we have space? No. Okay, here I am writing. If you solve it, you will get, this is the equation, minus 1 upon 360 I am keeping outside, and you will get a square minus 15a minus 24I. Okay, minus 24I. You will get this one. This is just a simplification part. This is just a equation solving method. You will get this one. So see, if you observe here, if we know a square, if we know a, if we know I, then this is just a addition subtraction part. If you know these three things, then you will get the value of a inverse. The question asked to find the a inverse. Okay, so did you know a? Did you know a? Yes, we know a value. It is given in the question. We know I, it is identity matrix. It is always same, 1 0 0 0 1 0 0 0 1. But what is the left thing is, we don't know the value of a square. We have to find the value of a square, then only we can find this whole thing. So if you have noted down, you remember this equation, because it will be come back again. Now we have to find the value of a square. So a square is what? A into a, 276 951 438. 276 951 438. Okay, so this is a homework for you. You have to solve by yourself, and if you solve it, you will get your answer as 91 67 67 67 uh, 91 67 uh, 67 67 91. It is coming like a identity matrix like thing. So suppose here in place of 91 you assume 1, in place of 67 you assume, in place of 91 you assume 1, in place of 67 you assume 0. You will feel like a identity matrix, but it is not an identity matrix by the definition. So as you see, it is very lengthy process, so I don't want to lengthen the time of your lecture, so I have skipped that part of solving. I have solved already and I have written the answer. You also do the thing, you will get your answer. Okay, now we know the value of a square. The only thing left to find the value of a inverse. uh, okay, so I'm writing here. Okay, this, so what we have to do, that now we are we have the value of A inverse is 1. Just a minute. 1 upon 360 1 upon 360, we have got A square minus 15A minus 24I. Okay, you have got this. Now put all the values. Square value 91, 67, 67, 67, 91, 67, here one, okay, 67, 67, 91. 15 times of A, so I'm just doing directly. You will get 30, 105. See the value of A and multiply it with 15. You will get this answer 90, 135, 75, 15, 60, 45, 120, and we have the value of 24I. So I multiplied 24 in the I, so you will get this value. Wait. 0, 0, 24, 0, 0, 0, 24. Okay, so this is the final step we have to come here, and now you see I'm solving one, remaining you will do. This is 1 by 360. Okay, 91 minus 30, just check these values. 91 minus 30 is 61 minus 24, it's coming 37. Similarly 67 minus 105, you will get minus 38, and 67 minus 90 you will get minus 23. So remaining you have to solve. This is a homework for you, and I am writing the answer for you. You will get this value minus 53. Okay, so the thing, that is the thing, this step we have done. Put the value of A square I in the characteristic equation, and we have find the value of A inverse. So now I am writing again the value of A inverse in a clean page. Minus is there, okay, I have not written there, you have write it down. Minus 23, minus 68, 8, minus 8, 52, 7, 22, minus 53. Okay, let us send this minus sign in this matrix, so you will get this answer minus 37, 38, 23, 68, 8, minus 52, minus 7, minus 20, 22 and 53. Okay, this is the inverse. Now you see the element, this is a multiplicated 1 upon 360. If I take in inside of the matrix, then every element will have a denominator 360, and if we add it, the 360 will become the LCM. So it is better to keep outside. That doesn't change anything. So the question we have asked previously is to find the value of A inverse, and we have to check that it is a magic square or not. So if you add here, now you have to add here, and here also given, let us write here. So if you add it, minus 37 plus 38, you will get 1, and 1 plus 23 you get 24. Add the second column, I mean second row, 68 and 8 is 76, and 76 minus 52 is 24. And the third row, minus 7 minus 22 minus 29 plus 53, it is also 24. Okay, actually answer has to come minus 24, but we have sent this minus sign in the matrix, and that's why we are getting the positive 24. Okay, so now I am erasing this upper part. Okay, I think you have written. If you have not written, just rewind the video and write down. Now let us add the first column. Minus 37 minus 7 is minus 44, and plus 68, if you add, it is coming 24. So if you add this second column, then 8 and 38 is 46, minus 22, it is 24. And if you add these two, 23, 53 is a 76, minus 52, you will get 24. And also once add the diagonal, minus 53 sorry 53 and 8 is 61. 61 minus 37, you will get 24. So but actually the answer is what, 24 by 360, which is 1 upon 15. This one, don't forget this 1 upon 360 we have written here. Actually this is the partial answer. This is the half answer, partial answer 24, but actual answer you will get 1 upon 15. So you see this is also a magic square. So I am writing the conclusion over here. A inverse of the magic square matrix is also a magic square. So this is our conclusion. This is our conclusion. A inverse of the magic square matrix is also a magic square. So today you have learned a new thing. You already know how to find inverse of a square matrix, and engineering students know the eigenvalues, eigenvector. If they already covered the first year, of course, first year or second year, if they have covered, then they know. So today we have learned that any magic square matrix is there which satisfying the condition of a square matrix and also the condition of magic square. If we are finding the inverse, then it is also a magic square matrix. It is a matrix because we are finding the inverse also by the matrix forms. We are finding the inverse, which is a matrix only, but the main thing, it has to follow the conditions of the magic square matrix. Okay, so I hope you understand this. So this is, yeah, we have checked the answer. This is all done here, and I have written the conclusion also. Now the task for you, this is another one question. Find the inverse of the magic square matrix. See, yeah, this is a very interesting matrix. It is based on APJ Abdul Kalam, because if you see the first row, it is a, it has written the date of birth. If you see, it is written 15 September 1931. It is the birth date of APJ Abdul Kalam, the missile man of India, and the president from 2002 to 2007 of our India. And this is the first row. If you read out, it is written 15 September 1931, which is the date of birth of APJ Abdul Kalam. So it's also a very interesting question, but very lengthy question. Try to solve it, and if you really find out that it is also in square matrix, then in the comment section, you just drop a comment yes. You just drop a comment yes. If not getting, then drop a comment no. And the percentage of yes or no, we will check out, and accordingly we have in the next class, if more number of no answers, no comments are coming, this no comments are coming, then we will try to solve this question also. Till then, try to solve it, and thank you for watching, and do also check our other research videos. We will try to give you more research videos like that, and we will also give interesting questions to you. So thank you for today. Bye bye and good night.